So first what we are going to do is we are going to write circuit elements in frequency domain. Okay, like how exactly you have to write upon applying the Laplace transform. So circuit elements in frequency domain. If I have a resistor in current domain, how you will write in frequency domain? Any change? No change. Okay, it will be a resistor alone, no change in that. So along with that, if there was I of t here, what you will have to write here? I of s. That's it, no change. Okay, but remember, if there was a constant current like this, let's say some I naught is there, what it will change when you're applying in the frequency domain? This is a constant value. I naught by s. Okay, please remember. Okay, constant value, if it is there, when you're applying in frequency domain, it becomes I naught by s. Next, coming to capacitor. So you have capacitor in current domain. What will be the expression for V of t? Capacitor in current domain. Capacitor in current domain, what is the expression? If this is C, 1 by C into integration I dt plus, always we have to remember there is an initial condition. So that is Vc of 0. Now when you apply Laplace transform to this one, what will be the expression? Integration 1 by Sc I of s plus Vc of, so by s. Vc of 0 I have taken from initial condition, remember. Okay, so now why I have written this? So that it will be easy for you to write the circuit. What does it has? One current component where there is a capacitive value plus one voltage component. Okay, so from this, if I want to find Z of S, how will you get me? Let's say only from this point, I want you to find Z of S. What do you think it is? V of S divided by I of S will be 1 by SC. Okay, so what I'm going to do, even though I'm going to write it as a capacitor, I will write the impedance of this particular part in frequency domain. So I'm writing it as 1 by SC. There might be a current. I'm not writing current as of now. Only the impedance part I'm writing. Please understand. Okay. Plus what else is there? What else is there? Vc of 0 by, so this is a voltage source plus minus Vc of 0 by S. Please write Vc of 0. Do not simply write Vc because it's a constant value. You have to consider the initial condition t equal to 0. Okay. The same thing I can rewrite as, see, that is based on the application. Okay. This is a actual representation in frequency domain, but you can rewrite it as a capacitor. The circuit, if you want to use, you can use. Otherwise, you can use capacitor in series with the voltage source. Okay. So this one remains same. Always I want to consider it as an impedance element. Here, it will be Vc of 0 by S. If I want to do source transformation, I want to do source transformation of this voltage source to current. How should I do? Divided by 1 by SC. So divided by 1 by SC. When I do that, what will I get? SS gets cancelled. Will the value will be CVC of 0? Yes. Okay. So that's what you have to write here. Understood, everybody? Source transformation of this particular voltage source to current source. Okay. So what I'll do, instead of writing all these, I will simply write here as C into Vc of 0. Understand? Okay. So now, if in case I'm going to ask you, here there is some resistor or whatever voltage. If I want you to apply nodal analysis, how will you do? Some voltage V naught here. How will you do? V naught divided by 1 by SC minus C Vc of 0 equal to 0. Understand? Okay. In frequency domain, you are considering this as not a capacitor. You are considering 1 by SC as the impedance element only. Okay. So using that, we will solve one numerical. Understood till here, everybody? Okay. So next part, we are going to consider the inductor. So there is a inductor. Let's say the inductance is L and the voltage is VL of T. Current is IL of T in L di by dt. Okay. L di by dt. Is there any initial voltage for this inductor? No, for inductor, there can be a current. Okay. Initial current, but not initial voltage. So here, anyhow, we are writing with respect to voltage. Let's see if that initial current comes up or not. Okay. Apply Laplace transform. VL of S is equals to L into Laplace transform of di by dt. S into I of S minus I of 0. Very good. So what happened here? We came to initial condition again. Okay. So that's what I wanted to mention. Capacitor, you will write when you are writing the expression for VC of T itself. Okay. Inductor, when you apply Laplace transform, you will get that initial current. Okay. So now again, I will write it as SL I of 0. So with this one, if I want to find the impedance component, what will be impedance component here? SL, that's it. SL is a impedance component, correct? So L into I of 0 is current component or voltage component? Voltage component, because these voltage, this is the expression for voltage. This is the expression for voltage. Another one should be voltage component only. But when I'm writing the direction of symbols, how should I write? Here minus is it. Ulta, that's it. Okay, so how exactly I will write the inductor now? Inductor, here SL, very good. Here L into I of 0. Please remember again, this became a constant. Okay, now if I want to write in terms of power, I am writing here inductor. Remember, I am considering the impedance component only. Okay, so what will be the impedance value changes? Same, SL. What will be the current? Voltage is L into I of 0. What will be the current? What will be the current? Voltage divided by current. Sorry, voltage divided by impedance component. So it will be L into I of 0 divided by SI. Yes. Okay. So I will rewrite directly as I of 0 by S. I of 0 by S. But tell me about the direction downwards. Very good. So downwards direction. Understood, everybody? Okay. So now if I ask you, write the circuit in frequency domain, you are supposed to use these components. Okay. Understood, everybody? Yes. So what I'll do, I'll just stop this recording.